Good morning, students. Students, as you all know, in our previous lectures, we did certain numerical problems on the calculations in solutions, that is the expression of a concentration in solutions. Now today, we come to the last topic of this chapter number 1, which is the basic concept of chemistry. It is the calculations based on chemical equations. Now, one thing you must be sure of, although in this curtailed syllabus, which is being given only for this year, this topic is deleted from the syllabus as you have done this in the class 10th also. But make sure this pandemic time is will get over, and when you appear for the entrance examination, the complete syllabus of the class 11th and 12th will come. So we'll be doing this topic again. This you have done earlier in the class 10th also. That is the calculations based on chemical equations. These are stoichiometric calculations. Calculations based on chemical equations are stoichiometric calculations. Stoichiometric calculations. Now, in this, we basically do three kinds of problem. That is the calculations based on mass-mass relationship, mass-volume relationship, and volume relationship. So we over here do three kinds of problem. These are the calculations based on mass and mass relationship. So calculations based on mass and mass relationship. Am I clear? Remember, we did this in the class 11th also, in the 10th also, mass-mass relationship. Second will be the mass and volume relationship. So calculations based on mass-mass relationship and then mass-volume relationship. Then we have a calculations which are based on volume and volume relationship. This is volume and volume relationship. Mass-mass, mass-volume, and volume-volume relationship. In the calculations which are based on mass-mass relationship, mass of one substance is given, and from that mass, the mass of other substance is calculated. As for example, let me take this example. Hydrogen, when combines with oxygen, it will result in the formation of a water molecule. If my question is, mass of hydrogen suppose is 10 gram, what mass of water will be formed? So from the mass of hydrogen, we have to find out the mass of water. That is, from one mass, the another mass is to be calculated. So what it will be? A mass-mass relationship. Just see over here. What is the mass of hydrogen over here? 2 into 2, this will be 4 gram. What is the mass of water over here? This will be 2 into 18, this will be 36 gram. So by the balanced chemical equation, what do we get? If we have 4 gram of hydrogen, what mass of water is obtained? 36 gram of water is obtained. Applying the unitary method, if you have 1 gram of it, what mass of it will be obtained? This will be 36 divided by 4. And if we have 10 gram of it, what mass of this will be obtained? This will be 36 divided by 4 into 10. So if we cancel it up, this will be 5, this will be twice and 5, and this over here will be 18. So answer over here in this case will come to be equal to 90 gram. Am I clear? So this is a mass-mass relationship. So from mass of one substance, the mass of other substance is to be calculated. This is called as a mass-mass relationship. Now, one thing you must be very sure over here. If mass of only one reactant is given, then from that mass, the mass of product is calculated. But if in any question, mass of more than one reactant is given, then the mass of a product obtained will be decided on the basis of a limiting reagent. What are limiting reagent or limiting reactant? The reactants that get completely consumed during the chemical reactions are called as a limiting reactant. So if mass of, suppose both of these are given, this will be calculated on the basis of a limiting reactant. So limiting reactant. What are a limiting reactant? The reactant that get completely consumed during the chemical reaction. Limiting reactant, the reactants that get completely consumed, that gets completely consumed during the chemical reaction, that get completely consumed during the chemical reaction, during the chemical reaction are called limiting reactant, are called limiting reactant. So reactant that get completely consumed during the chemical reactions is called as a limiting reactant. And the reactant that are left after the completion of the reaction are called as a excess reactant. So what are excess reactant? Excess reactant. The reactants that are left after left unused after the completion of chemical reaction, after the completion of chemical reaction, are called as a excess reactant. Let me explain to you this concept of a limiting reactant and excess reactant, again taking an example of a same reaction. Suppose reaction over here is hydrogen. Hydrogen when react with oxygen, it will result in the formation of water. In the question it is given as 10 gram. Here it is given as a 64 gram. My question is, if 10 gram of hydrogen react with 64 gram of oxygen, what mass of water will be formed? Am I getting clear? If 10 gram of hydrogen react with 64 gram of oxygen, what mass of water will be formed? In this question, the mass of two reactants are given. So the correct answer will be that which will be obtained from the limiting reactant. Limiting reactant will be that the reactant which get completely consumed during the chemical reaction. How to do this? The easiest way to do this, you calculate the mass of water formed from both hydrogen and oxygen. From whichever reactant the lesser amount of water will be obtained, that reactant will be called as a limiting reactant. Just see how I solve it up. In this case, the mass of hydrogen is what? 4 gram. From 4 gram of hydrogen, what mass of water is formed? This will be 36 gram. Am I clear? If I take the mass as 1 gram, it will be 36 divided by 4. And if I take the mass as 10 gram, this will be 36 divided by 4 multiplied by 10. And this will come to be equal to 90 gram as we did over here. Is it clear? Now let me solve how much amount of water is formed from water. What is the mass of water over here? 2 into 16, 32 gram. 32 gram of oxygen form what amount of water? This will be 36 gram. Is it clear? Now, if we take 1 gram of this, how much of this will be formed? This will be 36 divided by 32. If I take over here 64 gram as given in the question, 64 gram of this will be 36 divided by 32 multiplied by 64. Am I getting clear? This will be twice. And this will come to be equal to 72. Just see, when I use 64 gram of oxygen, what mass of water is formed? 72 gram. When I use 10 gram of hydrogen, what mass of water is formed? 90 gram. So in which case, lesser amount of water is formed? When we calculate by using oxygen. So over here, oxygen is a limiting reactant. In this case, oxygen is a limiting reactant. Why? Because with oxygen, lesser amount of water is formed. Is it getting clear? So, what amount of water will be considered to be formed? 90 or 72? Which one is lesser? 72. So answer will be 72 gram of water is formed. So always calculate from the limiting reactant. 72 gram of water is formed. So in this case, 72 gram of water is formed. Tell me whether it is clear or not. Yes? So 72 gram of water will be formed. If I ask you what is the name the limiting reactant? Oxygen. The reactant which is in axis, it will be hydrogen. So axis reactant in this case. Over here will be hydrogen. So axis reactant in this case will be hydrogen. Tell me whether it is clear or not. This numerical problem or this kind of a numerical problem you have done. So after mass-mass relationship, next is a mass and volume relationship. That is from the mass of one substance, the volume of other is to be calculated. That is a mass and volume relationship. Mass and volume relationship. So how to calculate the mass volume relationship? Mass volume relationship. Here again when I say the mass volume relationship, from mass of one, the volume of other is to be obtained, or from the volume of one, the mass of other is to be obtained. As for example, if I again take this example, if I say hydrogen, then it again reacts with oxygen and it reacts to form two molecules of water. My question is the mass of hydrogen is 4 gram, or I must say mass of hydrogen suppose is 10 gram, what volume of water in the form of steam or gas will be obtained? So what volume of water will be required, obtained? So from the mass of water, the volume of water vapor so formed is to be obtained. This will be mass volume relationship. Just see over here what is the mass of hydrogen. This is 4 gram. And how many mole of this water is formed? 2 mole. 1 mole of water will occupy what volume? 22.4 liter. So this will be 2 into 22.4 liter. Am I getting clear? If it is 4 gram of mass, what volume of water is formed? 2 into 22.4. If it is 1, what volume of it will be obtained? It will be 2 into 22.4 divided by 4. And if it is 10 gram, mass of one, the volume of other, it will be 2 into 22.4 upon 4 multiplied by 10. On solving it out, this will be twice, this again will be 5 times. Am I clear? So, if we multiply this one over here, so this will come out to be equal to 112 gram over here. So, 112 liter. Just check out. So, if we multiply this one, so this will come out to be equal to 112 liters. Is it clear over here, or 112.5 liters over here? 112 liters. I think I shall be very clear over here. Approximately this will be the answer. Now students, after mass-mass relationship and a mass-volume relationship, we come to volume and volume relationship. So volume-volume relationship. Volume and volume relationship. This we have done earlier also as Gay-Lussac's law of a combining volume. So this was basically a Gay-Lussac's law. In this case, from the volume of one reactant or from the volume of reactant, the volume of product is to be calculated. As for example, if I again take the example of this, hydrogen in the form of a gas combines with oxygen in the form of a gas, it will result in the formation of water vapors, and this water vapor is in the form of a gas. Suppose if it is given to us that we have 200 centimeter cube of hydrogen, then what volume of water vapors will be produced? So from the volume of one, the volume of other is to be produced. So what relationship? It will be called as a volume-volume relationship. Just see over here. What is the volume over here? It is 2 volume. 2 volume means what? It will be 2 into 22.4 liter. Am I clear? 2 mole volume. Here it is again how much volume of water is produced? It will be 2 volume. When I say 2 into 2 volume, so it means 2 mole volume. This will be 2 into 22.4 liter. So if the volume of hydrogen is 2, if volume of hydrogen is 2, then 2 means 2 into 22.4 liter. Then 2 volume of water vapors are produced. So if the volume of hydrogen is 2 volume of water vapors are produced. Similarly, if the volume of hydrogen is 1, then what volume of this will be produced? It will be 2 upon 2. You may also write it as 2 into 22.4 and 2 into 22.4. Am I clear? If the volume of this is 200 centimeter cube, if it is 200 centimeter cube, what volume of water vapor will be produced? It will be 2 into 200 centimeter cube. Am I clear? So this will come out to be equal to 200 centimeter cube. So from the volume of one substance, the volume of other substance is formed. Yeah, I may say volume of the reactant, the volume of product is formed. So this is called as a volume-volume relationship. Here in the volume-volume relationship again, if the volume of the 2 reactants are given, I repeat, if the volume of the 2 reactants are given, then the volume of the product will be calculated from the volume of the limiting reactant. Limiting reactant will be that which is being completely consumed during the chemical reaction. As for example, in this reaction itself, if I say we are given, suppose a 2 volume of, or I must say 200 centimeter cube of oxygen also. If in the same question it is given 200 centimeter cube of oxygen also. So I will be calculating the formation of water from hydrogen and oxygen, and in whichever case I will obtain the smaller answer, that will be considered to be right answer. So from this we have already calculated, from 200 centimeter cube of hydrogen, what volume of water vapor are produced? 200 centimeter cube. Now suppose if I calculate from oxygen, how much volume of oxygen is given over here? So if I calculate for oxygen, so for oxygen if I calculate, for oxygen over here, 1 volume of oxygen produces how many volume of water vapor? 2. 1 volume of oxygen produces how many volume of water vapor? 2 volume of water. Is it clear over here? From 1 volume of this, 2 volume of this is produced. If I say 200 centimeter cube of this, from 200 centimeter cube of this, how much will be produced? It will be 2 into 200. So it will come out to be equal to 400 centimeter cube. Is it getting clear? Here how much volume of water vapor were produced? 200. Here how much is produced? 400. In which case the lesser volume of this is obtained, water vapor. This is this. So in this case, this will be a right answer. Why? Because hydrogen is a limiting reactant. So hydrogen in this case is a limiting reactant. In this case, hydrogen is a limiting reactant. Okay? And what amount of water is produced? So water vapor produced will be 200 ml. So 200 centimeter cube of water vapor is produced. So over here, 200 centimeter cube of water vapor are produced. So 200 centimeter cube of water vapor is produced. Name the axis reactant over here. In this case, oxygen will be an axis reactant. So oxygen is an axis reactant. So axis reactant in this case will be oxygen is a axis reactant. I think all the 3 types of problem must be very, very clear to you. So today we have done the volumetric calculations, which are mass-mass relationship, mass-volume relationship and volume-volume relationship. And with this, we complete the theoretical aspect of this chapter. In our next lecture, we will be discussing certain numerical problems based on these topics, and then we will start with the new chapter, atomic structure. By that time, you revise your work. Please solve the questions given in the book. You will definitely feel comfortable if you solve all the questions given in the book. So, we will meet you again in the next lecture. By that time, thank you.